If you have lots of pieces of similar data that you want to store in one big collection and then pass them around your code together, then regardless of the programming language you're working with, you'll most likely have three options. In this video, we're going to go over the three most popular data types for storing a set of objects, and we can talk about when you'll want to use each one. Before we get started, just a quick note on programming languages. The three data structures that we're going to cover exist in a lot of programming languages in some form or another. For the examples in this video, I'm going to show you some code in C# and also in JavaScript, because that covers most of the differences between all the major languages, and it will help me better explain the underlying concepts of these different collections. So let's get into it. Arrays. An array is probably the simplest data type for storing multiple objects, and it's certainly the first one that you'll be introduced to when you're learning a programming language. Arrays store the items one after another in memory, and for most languages they can be dynamically sized and they don't guarantee any kind of ordering. You add items into an array and they just sit there in a sort of bucket addressable by index. The best way to think of an array is to imagine a line of bottles standing on a wall. The first bottle is propped up on the left here, and then you can go up and you can grab any bottle you like if you know the number along the wall that it is. In array speak, this number is called the index and it starts at 0. If you want to add a new bottle into your array, then you have two options. You can either put it into this space on the right hand side, so that's the end of the array, or you can replace one of the existing bottles with a new one. This is some JavaScript code that represents the same two operations. Here we have an array with 10 items, just like our bottles on the wall. And then we're adding an 11th item to the end. On this line, we're replacing the 5th item with a new string value. You can then pass the whole array around your code and access these items wherever you need them by index. Queues. The second type of data structure we're going to look at is a queue. Now, in most programming languages, a queue will still use an array behind the scenes, but it exposes some more functionality to us that changes the way that we interact with our collection of objects. A queue is often called a first in, first out collection because the first item you add into it will be the first item that comes out of it, just like a queue of people. Here, instead of bottles standing on a wall, we have a line of 10 people. Unlike with an array where we can just replace someone halfway along, with a queue, that's not generally what we do. If we need to add another person to the queue, well, they have to go to the back. If you want to take someone from the queue, well, then you have to go to the front and take this person here. If you don't do that, everyone else gets annoyed. So these are two operations that you have when you're using a queue. Adding an item to the back is called onqueuing, and removing someone from the front is called dequeuing. Here's an example in C#. C# has a dedicated type called queue. It's the same for Java and Python and probably some other languages too. This data type has these two methods on it, called queue and dequeue. So to add an item in to the end of your queue, you just call this method, and to remove an item, you call dequeue, and the return from this function will be the item that you removed. So I said at the start, I was going to show examples in C# and JavaScript as well. And that's because JavaScript doesn't have dedicated queue types, but you can do queues in JavaScript by utilizing these two methods on an array. So to create a queue in JavaScript, you simply create an array and then you call push to add an item to the end and then shift to remove an item from the start. So this is the equivalent of the onqueue and the dequeue methods in C# or Java. Okay, the final data structure that we're going to look at is the stack. And just like the name suggests, you can think of a stack like a stack of paper. We have a stack of 10 sheets here, and if you want to add an item, well, you have to add it onto the top of the stack. And if you want to remove an item, you have to remove it from the top. So unlike a queue, where you add items onto one end and you remove them from another, with a stack, you add items onto one end and then remove them from that same end. So a stack is called last in, first out collection type. Because when you take something off the stack, you'll get the newest item. That's the most recent item that you added. This is the opposite of a queue, where if you remember when we remove an item from a queue, we get the oldest item. So that's the person that would join the queue first. Here's a stack implemented in C#. As you can see, there is a special stack class. Here I've declared it as a stack of strings. And then we use these two methods to add an item onto the top of the stack and to remove the item again, also from the top of the stack. In JavaScript, just like with the queue, we just use an array and we call push and pop on this array in JavaScript to replicate the functionality of a stack. So have a think about when you might use a stack versus a queue. Stacks are useful for things like tracking a history of operations. Your browser history, for example, is a stack. When you visit a new page and you add it into the top of the stack with a push, and then if you need to go back by hitting the back button, then you just go into your stack and take the topmost recent history item off the top. Queues, on the other hand, are useful for when you need to keep and preserve the order of when things happened. So message queues are an extremely popular tool for building asynchronous systems. In a message queue, each write operation or each event is added into the queue, and then you have some code running at the other end of the queue that removes items one by one and processes them. And you process them in the order that they were added into the queue. Anyway, I hope this video has been helpful and given you a bit of an overview into these three collection data structures. If you have any questions, please ask them in the comments below and I will get back to you. My channel is still very small, so I can reply to every comment and I will do that for sure. So while we're on the subject of my channel, please remember to hit the subscribe button and check my other videos. My name's James Charlesworth and this is the Train to Code YouTube channel.